Good day everyone. Welcome to my class. Today we are going to talk about science, and by the way, it's me, Ma'am Princess, and I'm going to guide you regarding our topic for this day. So today we are going to talk about the calculation of the second law of motion or the law of acceleration. In calculating the second law of motion, do not forget this triangular formula wherein there are three variables which represents as F equals to force, M stands for mass, and A stands for acceleration. Now take a look at this triangular formula. You will notice that there are two lines, which is horizontal and vertical line. In horizontal line, it represents the division operation, and in vertical line, it represents the multiplication operation. Now, if you're going to look for the value of F or force, you just need to remove or cover it. So therefore, the correct formula is F is equal to M times A. Now, if you want to look for the value of mass or M, you just need to cover it, okay, or remove it. So therefore, we have here FA. So the formula for mass is F divided by acceleration, or force divided by acceleration. Now, if we want to look for the value of acceleration, you just need to cover it. So therefore, we have here F and then M. So the correct formula for acceleration is force divided by mass. So there you have it. We have here now the three basic formula for the three variables of the law of acceleration. If you're going to look for force, you just need to multiply mass and acceleration. If you are looking for mass, you just need to divide force and acceleration. If you are looking for acceleration, you just need to divide force and mass. So in order for you to better understand this lesson, let us have an example of our law of acceleration. So here, we have problem number 1. In our problem number 1, you're going to solve for the amount of force being applied by a girl as she pushed a 4 kilogram box with an acceleration of 0.6 meter per second per second. So, if you're going to plot this using GRESA, so what you're going to do is to substitute the value of the following variables on the given problem. So GRESA stands for G as given. So based on the problem, we have here a 4 kilogram box and a 0.6 meter per second acceleration. So 4 kilogram from its unit is obviously the mass of the box. Next, we have acceleration, which is equal to 0.6 meter per second. Now, after G, we have R. R stands for required, or what is unknown. Now, going back at the question, how much force? So definitely, you already know that you are looking for the value of force. So that is required, or the unknown. Next, we have E. E stands for equation. In triangular formula a while ago, you already know that F is equal to mass multiplied by acceleration. Then we have S, which stands for solution. Since we are looking for force, you just need to substitute the value of mass, which is 4 kilogram, and you just need to multiply it, or you just need to use the open and close parentheses, and it represents the multiplication operation. Now, substituting the value of acceleration, we have 0.6 meter per second. I will repeat, the value of acceleration here is 0.6 meter per second. Now, you just need to multiply 4 by 0.6. And then, correct answer is 2.4 kilogram meter per second, or meter per second squared. Now, let us have our final answer. Force is equal to 2.4 Newton. So where did I get Newton? The expanded form of Newton is actually kilogram meter per second, or kilogram meter per second squared. And then the short term for this is Newton. It must be capital letter because it represents the standard unit of force, which is actually after the scientist who discovered the three laws of motion, which is Isaac Newton. Next. So, there you have it. Problem number 1. For problem number 2, solve for the acceleration of a 4 kilogram box being pushed by a girl with 15 Newton. Again, you need to use GRESA. So from here, you just need to underline first the given, such as 4 kilogram box and 15 Newton. Now, let us have given, or G. We have here 4 kilogram, and we already know that kilogram is the basic or the standard unit, for mass. And then we have here 15 Newton, and we all know that Newton is the standard unit for force. So from here, you already have the variable of mass and force. So this is very obvious that the unknown or the required is acceleration. So here, you need to look for the value of acceleration. Okay? So after the required, you have equation. So in order for you to get the correct formula, you just need to go back at the triangular formula that I gave a while ago. And we all know that acceleration is equal to force divided by mass. So F over m. Now let us try to solve the given problem. So in the given problem, or problem number 2, you just need to substitute the value of force, which is 15 Newton. And in solving for the value of acceleration, you need to expand the unit of Newton, and that is kilogram meter per second. The meaning of expanded form is you need to make the standard unit of Newton longer, or in its longer form. So, over 4 kilogram. So, you need to solve for the value of acceleration. So, you need to divide 15 by 4. What is 15 divided by 4? Okay, you are correct. 15 divided by 4 is 3.75. So 3.75. Now, you will notice that the units here of mass are 2. Here we have kilogram and another kilogram. So you just need to cancel the units that are the same. So what are the units that are left here? We have meter per second. So you just need to write meter per second, or meter per second squared. So let us have now our final answer. Acceleration is equal to 3.75. You can make this in a short form, which is meter per second squared. Remember that the unit for acceleration is meter per second squared. So there you have it. We have 3.75 meter per second squared. Next, let us have problem number 3. How heavy is a box if it has an acceleration of 2 meter per second and being pushed by a 20 Newton force? Use GRESA. So G stands for given. So let us underline 2 meter per second and 20 Newton. From the unit meter per second or meter per second squared, we already know that this is an acceleration. So you just need to write 2 meter per second. Next, we have here 20 Newton, and Newton is the standard unit for force. So you just need to write 20 Newton. Okay? Next, we have required. So what is the required or the unknown value or variable? How heavy? So it pertains to the mass of an object. So since you already know that you are looking for the mass, you need to go back at the triangular formula and look for the correct formula of mass, which is equal to force divided by acceleration. And then after that, you need to solve for the value of mass. So mass is F divided by A, or acceleration. You just need to substitute the value of force, which is 20. In solving, you need to expand the unit of Newton, and expanded unit of Newton again is kilogram meter per second squared or meter per second divided by the value of acceleration, which is 2 meter per second. So you need to divide 20 by 2. So the correct answer is 10. So take a look at the unit. Are there units that are the same? Yes, you are correct. So we need to cancel meter per second and another meter per second. And the remaining unit here is kilogram. So since you already get the correct unit for mass, you need to give the final answer, wherein mass is equal to 10 kilogram. So we have here the correct answer for problem number 3. Mass is equal to 10 kilogram. So see, it's just easy if you're just going to remember the triangular formula that we are always using in solving and in calculating the second law of motion. Now, let us have the fourth example. Here, you really need to focus because this is a little bit different from the example that I gave from 1 to 3. So, let us read the problem. A 4 kilogram cart is being pushed by a man and speeds up from 4 meter per second to 10 meter per second within 2 seconds. How much force is exerted by the man if the cart has a 6 kilogram box? So you will notice that there are actually a lot of given in this problem number 4. So again, you're going to use GRESA. So let us now have the given. We have here 4 kilogram and here we have 6 kilogram. So 4 kilogram is the mass for cart, while 6 kilogram is the mass for box, right? So if you're going to solve that, in a cart which is 4 kilogram, there is a box which is 6 kilogram. So if that is the case, your mass is equivalent to 10 kilogram because cart and box are working together. Now, you already have the mass. How about this 4 meter per second and 10 meter per second? It speeds up from, so meaning to say, this is the initial velocity or speed okay, which is from, so this is the starting 4 meter per second. Next, we have final velocity. So from 4 meter per second, the cart speeds up to 10 meter per second, right? And then the time is equivalent to 2 seconds. And you will just write seconds. Okay, I will put it whole. So, you notice that it's something or somehow different from the example that I gave from 1 to 3. But don't worry, because what you are looking for is for the amount of force. And you already know that the required here or the unknown here is force, right? Force. And the correct equation for force is equal to mass, equals to mass times acceleration. You already have 10 kilogram, so you can already solve for the value of mass. Substitute for the value of mass. But you cannot substitute for the value of acceleration since there are two velocities that are given in the problem. So we need to look first for the value of acceleration. So acceleration has a formula of final velocity minus initial velocity divided by time. So if you're going to substitute the value of final velocity, which is 10 meter per second minus 4 meter per second divided by the time, which is 2 seconds or S. So since there will be no units that are the same, so you just need to copy this one. So let us now have the correct answer for acceleration. So there you have it. 10 minus 4 is equal to 6 divided by 2. So the correct answer for acceleration is 3 meter per second per second. Here you will notice that meter per second on the top is just copied and the second at the bottom is being placed. So this is the correct answer for the acceleration. We have here 3 meter per second squared. So going back to our problem, so we already have the value of acceleration, which is 3 meter per second squared. So you can already solve for the value of force. So let us have our solution. So force is equal to the mass, which is 10 kilogram, multiplied by the acceleration, which is a while ago, this is 3 meter per second squared. I will just put squared, or per second, it's just the same. Okay, so you need to multiply 10 by 3, very elementary. So the correct answer is 30. No units are the same, so you just need to copy the units. Kilogram meter per second squared. So since the unit is still in expanded form, your final answer for force is equal to 30 Newton. Where did I get the Newton? It is the same with kilogram meter per second squared. So, don't forget that if there will be two masses that are given, two velocities that are given in the problem, you need to solve for the acceleration first, which is final velocity minus initial velocity divided by time. And after that, that's the time that you can solve for the value of force. And the formula is mass times acceleration. So I hope that you already know the way you're going to solve and calculate the law of acceleration or the second law of motion. So here's the summary of our discussion. If you're going to look for the formula of force, it is equal to m times a. You just need to remove or cover or erase the f here. Now, if you want to look for the formula of mass, okay, so we have here F divided by M. F divided by A, or force divided by acceleration, if you're going to look for mass. And then, if you are looking for the value of acceleration, you just need to cover this. And we have here force divided by mass. Okay? So, let us have now the way you're going to answer and check your understanding. So, be ready as we have our activity. Okay. Problem number 1. How heavy is a box if it has an acceleration of 3 meters per second and being pushed by a 30 Newton force? You need to use Gressa. So I'm giving you only 1 minute to answer this one. So you are looking for what? How heavy? So it pertains to the mass. So we have here the given, we have here the required, we have here the equation, solution, and then answer. Always box your final answer. Okay? So we have here 3 meters per second and 30 Newton. So you may start solving by yourself. Okay, so let us have here the given acceleration, which is 3 meters per second, and we have here the force, very obvious because of the unit Newton, 30 Newton. So how heavy is the box? So the required or the unknown value of mass. Okay, so again, you are looking for mass. Next equation. Since you're looking for mass, we already know that mass is equal to force divided by acceleration. Now let us substitute the value. Mass is equal to force, which is 30 Newton. In solving, you need to expand the unit of Newton, which is kilogram meter per second squared, or meter per second, and then divide it by the given acceleration, which is 3. Okay, wait, I'm going to erase to make it clear for you. So we have here 3 meter per second. Since you will notice that in the given solution, there are the same units for the upper part and lower part, so you need to cancel it. And the unit that is remained is kilogram. So very obvious that you are heading on the right track in solving for the mass. Now let us divide 30 divided by 3, and that is 10. Since the remaining unit is kilogram, so your answer is mass is equivalent to 10 kilogram. Okay, so I hope that you have the same answer with me. Very good. Let us have another example for you to test your understanding. Again, you have only 1 minute to solve for the given problem. How much force is applied by a boy if he is pushing a 6 kilogram box with an acceleration of 0.7 meter per second per second? So you are looking for force. So use GRESA. We all know that G stands for given. So we have here 6 kilogram, and 6 kilogram stands for the value of mass. So you need to write here 6 kilogram. There you have it, 0.7 meter per second, and this is very obvious that this is acceleration. So you need to write 0.7 meter per second or meter per second squared. Now, from the question, the unknown variable is force. So you are looking for force. Next, the equation for force is actually very easy. Force is equal to mass multiplied by acceleration. Wait, I'm going to make it clear for you. I'm going to erase it and do it again. So we have here mass multiplied by acceleration. Now let us have our solution. So force is equal to, what is the given mass? We have 6 kilogram. There you have it. You need to multiply it by 0.7 meter per second or meter per second squared. You can have an exponent, okay, or raised by 2. Now, you need to multiply 6 by 0. This is 0.7. Okay? So, what do you think is the correct answer if you're going to multiply 6 by 0.7? Okay? So, the correct answer is, since that is 6 times 742 and there's decimal point, 1 decimal point, so the correct answer is 4.2. Now, there are no units that are the same, so you need to copy the 2 units here, such as kilogram, meter per second squared. Now, we already know that the standard unit for force is Newton, so you can have your answer as force is equivalent to 4.2. Wait, I'm going to erase it again, the 2. Okay. So we have here 4.2 Newton, as simple as that. So the correct answer for this problem is 4.2 Newton. Okay. Next, last problem. Solve for acceleration. You can do it by yourself already. So I'm just going to underline here 4 kilogram box and 15 Newton. That's so easy. Use again GRESA, because if you're going to use GRESA, you are already guided on the right track of solving the or calculating the law of acceleration. So we have here given, then we have here required, and then we have here equation, and then you have here solution, and then you have answer. So, let us now solve. So, we already know that mass is equal to 4 kilogram. And then, force is equal to 15 Newton. Why force? Because the clue here is always the unit, and Newton is the unit for force. Since, from the question, you need to solve for acceleration. So the unknown value or the required value that you need to solve is acceleration. So we already know that acceleration is equivalent to force divided by mass. Now for the solution, acceleration is equal to force, which is, you need to substitute 15. You need to expand also in Newton as kilogram meter per second divide it by the given mass, which is 4 kilogram. Now, you need to divide 15 by 4. So, 15 divided by 4. Okay, the correct answer is 3.75. Since there are 2 units of kilogram, so you need to cancel. And the remaining unit is meter per second. You can also make this meter per second in the simplest form. So our answer is acceleration is equal to 3.75 meter per second squared. And then don't forget to box your final answer. So very good. We are now done with the 3 problem. So it seems that based on the way you are able to solve the problems on our check your understanding part, so you are very good, guys. So keep it up. So it seems that we are already done with our lesson for calculating the second law of motion. Thank you everyone for listening. I am again Ma'am Princess Margaret Paz, science teacher. See you on my next video. Thank you.